This video is about arithmetic shifts, doing a division. Well, what is an arithmetic shift? Well, it's a way of taking a binary number like this and, in this case, dividing it by one of these numbers. And so on. So what are these numbers? Well, you can see that they are all powers of 2. Okay, so 2 times 2 is 4, 2 times 4 is 8, 2 times 2 times 2. You can see that this is 2 to the power of 1, 2, 3. 2 to 3 is 8. So an arithmetic shift is a way to multiply or divide a binary number by a power of 2. And that's what this is. And what I've done is I've grouped together arithmetic shifts and logical shifts because they both perform the same thing. They both allow you to multiply or divide a binary number by a power of 2. But why have two systems that do the same thing? Well, arithmetic shifts do this on signed numbers, which is positive or negative. And the logical shift will do this on unsigned numbers, which are always positive. And if you don't know what these words mean, you need to watch my videos on that. Also, you need to know what 2's complement is and how that works. Otherwise, this will not make sense to you. So, let's perform an arithmetic shift on this number. Let's say we want to divide it by, let's say we want to divide it by 8. Okay, so how do we do that? Well, first I need to know what 8 is as a power of 2. Well, 8 is 2 to the 3. And that's important because it tells me this, which is the shift value. I now know that I need to perform a shift of 3 places. Secondly, this division tells me that I'm doing a right shift. Okay, so those are 2 bits of information I need to know before I begin performing the shift. So now I'm ready to perform the shift. I'm going to write out the place values. What I'm going to do now is take the MSB, and if you notice the 2's complement system, this will make sense to you. I'm going to take the MSB and I'm going to drop it straight down. Okay. The next thing I'm going to do is I look at my shift value, and it tells me actually I'm going to copy the MSB 3 times. So here's 1, here's another, and here's a third one. So that's 3 copies of the MSB. Now I'm going to shift the rest of my binary. So this 1 gets shifted 3 times. 1, 2, 3. And then actually looking at it, the rest are all just zeros anyway. So I'm going to drop in the zeros. So let's recap. An arithmetic shift allows you, in this case, to divide a binary number by a power of 2. 8 is a power of 2. It's 2 to the 3. So the division I'm doing is this binary number divided by 8 hopefully should equal this binary number. Well, how do I know? Well, if you look at the blue binary number, actually the only thing switched on is 64. Okay, so it's positive 64. Positive 64 divided by 8, well, look at the answer, it's 8. Okay, so 64 divided by 8 equals 8. The binary for 64 divided by 8 equals the binary for 8. Why? Because only the 8 is switched on. Okay, that's it. Let's do another one. Okay, so this time I'm going to take minus 112, all right? And here is the binary for minus 112. 1, 0, 0, 1, 0, 0, 0, 0. And let's say I want to divide it by, I don't know, 2 to the 1, which we know is 2. So how do I do that? Well, number 1, let me observe that this is my shift. I'll observe that a division means a right shift. I'm going to write out my place values. I'm going to drop down my MSB, and then I need to duplicate it. Well, how many times? Well, just the once. So here's my 1 copy of my MSB. And now I need to shift everything to the right by one place. So that 0 gets shifted to there, this 0 gets shifted to there, that 1 goes there, 0 goes there, 0, 0. So how do I know this is right? Well, let's have a look. Minus 112 divided by 2 to the 1, well 2 to 1 is 2, so minus 112 divided by 2, that should equal 56. So is this orange binary the binary for 56? Well, you just do a quick bit of maths and hopefully you can figure it out. So I know I've got minus 128, but I've got to take away from that a 64, and what's that? Just an 8. Okay, so what's 64 plus 8? That's 12, that's 72. So what's minus 128? Take away 72. Got 8, take away to 2 is 6. I can't do that, so I borrow from that, and that becomes 12. 12 take away the 7 leaves me with 5, minus 56. So is that correct? And the answer is yes, it is. Assuming that this is minus 56, which it is. So I've got the binary in blue for minus 112, and I'm dividing minus 112 by 2, and that definitely equals the binary here in orange for minus 56. Okay, I'll do one more, and then we'll try some, you can try some examples. So let's say we've got the binary for minus 88, which is 1010, 1000, and I want to divide this by 2 to the 3. Okay, so first thing I'm going to do is write out my place values. I'm going to just make sure I understand that I'm shifting it by 3 to the right. Then drop down my MSB, copy my MSB 3 times, 1, 2, 3, and now shift the rest of my binary by 3 positions. So that 0 goes 1, 2, 3, and what follows it is a 1, 1, 2, 3, 1, 2, 3, 1, 2, 3. There. So I perform my shift. Minus 88 divided by 2 to the 8. Well, what's 2 to the 8? 2 to the 8 is 8. So minus 88 divided by 8 should equal 11. If I know my 11s times table, 11 eighths are 88. So the question is this orange binary indeed the binary for 11? Well, let's find out using the 2's complement method. So I've got a minus 128, and I've got 64, 32, what's that, 16. I'll do those, and I'll do the next nibble anyway. So 6 and 4 is 10, that's 12. I'll put the 1 there. 9, 10, 11, so I've got 112 plus 112 plus 4 is 116, plus the 1, so 117. That's fine. But I need to subtract that from 128. So I've got minus 128, take away the 117. I've got 8, take away the 7 leaves me with 1. I've got 2, take away the 1 leaves me with 1, and that leaves me with nothing. So I get 11. And obviously it's minus 11. So the answer is yes. The blue binary, which is minus 88, divided by 8, does in fact equal the orange binary, which is minus 11. And that's it. That's how you perform an arithmetic shift, specifically in this case division, with either positive or negative numbers. Okay, so grab a pen and paper and get ready to have a go at these, and then I'll reveal the answer. So let's try 0, 1, 1, 0, 0, 1, 0, 0, and let's say you want to divide that by 4, and another one 1, 0, 0, 1, 1, 0, 1, 0, and let's say you want to divide that by 2. Okay, so press pause, grab a pen and paper, and then have a go, because here come the answers. So 4 is the same as 2 to the power of 2, because 2 times 2 is 4, which now tells me my shift is 2, and the division tells me I'm doing a right shift. I'm going to draw out the place values. I'm going to drop down my MSB. In this case, it's a positive number. And I'm going to make 2 copies of my MSB. So that's 1, that's 2. And now I'll shift the binary by 2 places. 1, 2, and follow that 1, 1, 2, 1, 2, 1, 2. Now, is that correct? Well, let's have a look. I know that the blue binary is positive 100, and I'm dividing it by 4, which should equal 25. So the question is the orange one, is that the binary for positive 25? Well, let's have a look. I've got a 16, I've got an 8, and I've got a 1. And that adds up to 15, 25. Yeah, so that's right. That does equal positive 25. Let's have a look at this next one. So for this one, well, I know this is the binary for minus 102, and I'm dividing it by 2, which hopefully equals minus 51. So the question is, let's see if we can get the answer for minus 51. Well, 2 is the same as 2 to the 1, which provides us with our shift. And a division means we're doing a right shift. Write out the place values. The MSB gets duplicated, and it also gets copied across 1 time there. Then we're shifting all the binary to the right by 1 place. So that 0 goes there, that 0 gets copied across there, that 1 goes there, that 1 goes there, that 0 goes there, that 1 goes there. So hopefully the blue binary, which is minus 102, divided by 2 should equal 51. So the orange binary should equal 51. Let's check that it does. So I've got a minus 128. I also have a 64. And I've got a 8. And that's still on the screen. And I've got a 4. Well, I'll do the one as well in a minute. So 8 plus 4 is 12, plus 4 is 16, and 6 1 is 7, and actually it's 77. So minus 128, minus 77, let's see, I've got 8, minus 7 gives me 1, can't do this, so that becomes 12. 12 minus 7 is 5, so yes, that's just off the screen. But actually, yeah, the answer is indeed 51.